Following on from the previous video, we got to this stage here where if the angle is 0, then the area of the segment will be 0. The area would be 0. The area of the segment would be 0. But now suppose you increase the angle slightly. Increase it. Give it a small angle, delta theta. So with a small change in the angle, then you would get the ratio divided by the whole angle here, which is 2 pi, and then you would times the whole circle. That will then give you a small change in the area. And we got to this stage here. So a small change in the angle, combined with this, will result a small change in the area. And so the relationship is given by this. A small change in the angle, combined with this, and it will result in a small change in the area. Now let's look at this. Let's say we've got a, let's say this is our graph in polar coordinates. So because we want to work out the area, here, we would approximate it to this. Let's extend this here. So this is so this is the true area here, but we're going to approximate it to this whole thing here. So this is our error. This is our error. So now starting on the right hand side here, we would approximate it like this. So this is our error here. And then right hand side here, approximate it. So it's like this. So this is our error here. And then this one here is good. So it's dead on. So it's okay. This one here. So we would approximate it to this. So I hope you can see that this is very similar to Riemann sums here. We've done this in the past. Delta x here. So this distance here is delta x, and then you would get the once you've got your delta x here, once you've got the width here, you would need to times the height. So remember, we can use the right hand side, the midpoint, or the left hand side. Let's just choose the right hand side. It could be anywhere. So we would choose the right hand side. So once we've got a width, we would need to times it with a height. That will result in a small change in the area. So we spent a long time trying to understand this. We spent a long time in order to get from here to here. So as you take the limit of delta x, as delta x tends to 0, then the area, the error will tend to 0. As delta x tends, as you make the width thinner and thinner and thinner, the error here will be next to nothing. It will head towards 0. And we spent a long time in trying to understand how to get from here to here. So as you take the limit, look back on the fundamental theorem of calculus 1 and 2. We spent a long time trying to get from here to here. So as you take delta x, as delta x tends to 0, then we can say the dA equals this thing here. So we spent a long time in trying to understand how to get from here to here, and then you would then integrate both sides. Then that would then give you this. And remember, also we spent a very long time in order to get from here to here, because we spent a long time in trying to show that if you have a function here, if you differentiate the area, then it would give you the function itself. And you might have to track back to the fundamental theorem of calculus 1 and 2. If you can understand this, then you can see that this is very similar to this. We spent a long time trying to understand this bit here. So I hope that if you can accept this, then you can accept that the two are very similar. A small change in the angle combined with this will result in a small change in the area. Remember, this here is what we did earlier in the previous video. You see, a small change in the angle, combined with this will result a small change in the area. Now look at this. Hang on. A small change in the angle combined with this will result a small change in the area. And now take the limit as delta theta. So this here is delta theta, the small change in the angle. decrease the small change in the angle, take the limit as delta theta tends to 0, then you can jump from here to here and then integrate both sides. So the area is given by you evaluating this from one angle to another angle. If you can understand this, then you should be able to understand this. But understanding this takes a very long time, and we spent a long time in being able to get from here to here. So overall, the area is given by this, and we will make use of this in the next video. Okay.